All right, this unit is over chemical reactions. So there's 5 types of chemical reactions. Synthesis is the first one. It's also called combination because you're combining your 2 reactants into one product. So these could either be A and B here, could either be elements or compounds. Either way, they'll combine and form one compound. Then we have single replacement, where you start with an element, a single element, and a compound. And what happens is your cation is going to go to the other compound. So it switches places. Double replacement, 2 of your cations swap. They switch places. So here you're starting out with 2 compounds. Then we have decomposition, so you have a single compound or molecule, and it's going to break apart, and it can break apart into smaller compounds or into elements. And then the last one is combustion. So the pattern to look for in this one is you'll have some sort of hydrocarbon, which is just carbon attached to hydrogen, and sometimes it has a oxygen in here, but you have to have carbon and hydrogen. And then you're going to add oxygen gas always, and then on the product side you'll always have carbon dioxide and water. All right, so then we're going to have to balance these because the law of conservation of mass says that you can't create or destroy matter. So your chemical equations have to be balanced. So what you're going to do is you're going to count the number of atoms of each type of element that are on both sides of the arrow. Balance the elements one at a time, and the only thing that you can do is add coefficients. You can't mess with the subscripts. And I usually like to do metals first, then nonmetals, then hydrogen, and then oxygen. Okay, and then just make sure you double check and make sure it's balanced. Okay, so here you want to find your arrow. Just draw a line. So this side of the arrow, these are your reactants. They're coming together and reacting, and these are your products. This is what you're making. So start with your metals. We have 1 potassium over here. We have 3 potassium over here. So what I do is I put a 3. Now this 3 will go to everything that's in this compound. Okay. Then I like to balance the polyatomics as a unit. So if you notice, this is PO4. Well, here's PO4 too. So I'll balance those as a unit. 1 here, 1 here. So we're good. Then let's do our hydrogens. So we have 3 hydrogens from this compound. We have 3 here, so for a total of 6. And then here we only have 3. So we need 6. 3 times 2 is 6. So then let's check our oxygens. We have 3 oxygens here, plus 4 here, so that's a 7. Here we've got 4, and remember this will go here, so that's 3, so that's 7. Alright, so we're good. So if you want to fill in the blanks with ones, you can. Alright, find your arrow. The left has to equal the right. We have 1 nitrogen, 1 nitrogen, so that's good. We have 3 hydrogen, 2 hydrogen. Okay, so I need to find the smallest common factor between 3 and 2, which is going to be 6. So 3 times 2 is 6 over here, 2 times 3 is 6 over here. Oh, now I've changed my nitrogen, right? Because this 2 distributes to everything in the compound, so I need 2 nitrogen over here. All that's left is oxygen. I have 2 oxygen here. I have 2 plus the 3 from this side, which is 5. Okay. Now I have 2 here, so I can't do half of a molecule. So when this happens, if you have a 5 here, go back and double everything. Not if you have a 5 here, but if you can't divide into a whole number, just go back and double everything. And this happens most often with combustion reactions. This is a different kind of combustion reaction that you'll see in AP chemistry. All right, do these problems and we'll check your answers in class.